So
So
if you're willing to do the calculations yourself, then you're saying you don't necessarily get all
you
the
don't
other
need the you
baggage.
make it sound hard, but those calculations are not hard, really. What Sergey is saying basically is make this thing a sensor, and what that's going to do is it's not going to have any response then. Response being is that it's not going to bounce, it's not going to push, it's merely going to detect the collision. So it comes in, it detects that it has a collision, and at some point in your code you say, okay, either immediately when it makes the collision or momentarily afterwards, I'm merely going to, let me start this over again so you can see it. So at this, say, like at this point it had the collision, then your code could take over and say, move the body over to the center, say, oh, it was moving left, that means now it needs to move up. So you do that little bit of part where you change the velocity, you recenter the piece where it's supposed to be, and everything is good. You maintain the correct alignment of your path and your pieces. It's not a hard calculation.
Okay. Well, let's continue with the
Yeah,
thing here.
so before I lose my train of thought here, sorry. Uh, okay, so what did we discover here? The first trick for this is to move the point of collision such that the center of the body is in the center of our virtual path. But this is not good because it's kind of ugly. So let's make it a little better. So step 5, the other thing you'll notice about Ichi is that the ball is not the same size as the blocks or the bumpers. So as previously in my sample here, these were not exactly the same size, but this was very close to being as big as the full-on square here. And that's not what you want. I'll show the trick, the code, in a minute. But my trick to doing this calculation is based on the radius of the ball. The smaller the ball is, the closer this shape can be to the size of the full block. So now, this ball has a much smaller radius. As you can see, the point of collision is almost now at the point of the path, which gives us visually this impression that it's bouncing off the center and staying on the path. But in fact, it's not. And I just want to reiterate here is if you look at this Ichi example right here, you can see that these two blocks are misaligned, and that is because these blocks are slightly smaller than the full-on block. So let's run it and see that it still in fact works. Okay, good. So that still in fact works. Point of collision is here, center is here. As it has the collision, it stays on path. Let's make it slightly better. I think I need to go into hybrid mode at this point. In fact, let's do hybrid mode, staying on step 5. And yeah, I've already applied the trick. So in step 5, while the physical representation, the drawing part, looks this big, it's really hard to see, but the radius of the body is 80% of the radius of what I've drawn. In other words, it's smaller. So what that lets me do is make this bit real tiny, but approximate, because your eye can't track all this. It's going to look like the collision looks right, but it doesn't.
So you have a normal size ball, but your
Body is smaller.
the body is smaller.
The
So
physics body is 80% the size of the ball, which lets me make this piece bigger, and the collision point happens closer to the center. And because the eyeball, it's all blown up here, but when you look at it in a smaller puzzle piece size, on your little screen, you can't tell. This is version 6. As you recall, one of the other things they do in Ichi is they throb the body, which again fools the eyeball. What people need to realize is that in Corona, when you scale when you scale the object and it has a body attached, the body does not change size. It does not scale with the scaling. They trip up on this all the time. They create an object, they add a body, and then they scale it to like twice, and they're like, why is the body not coming along? The reason is that's just the way it is. I don't know what the reason is, but I'm sure that it's difficult to do after the fact. So if you want the body to match the size of your object. You have to have scaled it previously.
So you're
But
so, you, so you're saying I'm just going to make sure I'm clear. So you're saying visually when you make the object look bigger,
mhm.
the body itself is still the same size.
Yeah, let me
The
make this
original
more.
size.
Where is the code? Let me find the code. Oh, I'm looking in the wrong place. Hold on. Let me find the throbbing code and make it really obvious.
Because yeah, that would definitely be a point of confusion. Like, why isn't it acting the way I think it should?
Okay, now I made it 2
Uh,
times larger. So you see how big the body's getting?
yeah,
Like
now
this
it's
little green
obvious.
part?
Yeah.
That's the physical body. I keep saying body. The image gets larger, but the body stays the same.
The
So
physics object stays the same.
Yeah.
I think if you apply
the
-1,
physics object stays the same.
it will change.
Say again?
I think if you apply -1, like x scale -1 or y scale -1, it will flip. So it's
Right. Absolutely. Okay, that's right. Sergey is saying is if you use the negative scaling flips the image, but it also flips the body. So Corona's smart enough for the body to track the mirroring or the flipping of the image, but it's not going to adjust the size of the body relative to the scale, just the orientation.
Interesting.
So,
Okay.
so we've given more expert tips here on dealing with the physics engine. First of all, changing the scaling of the physics object itself so it's slightly smaller than your object to improve your collisions, which is what Ed did with the circle. And then that scaling doesn't happen post adding the physics body to a display object.
Absolutely. So as we can see, this is better, and I'm just going to run step 7, and then I'll show you the trick code, and then we'll go and I'll show you the editor and the other thing. So, okay, so this is step 7, and let me turn off the physics body, or the, I'm sorry, the hybrid mode. Now, if we watch it, it feels better. Now, obviously, it's still blown up, so we can see how it overlapped. But if it was moving at a higher rate of speed, you wouldn't really necessarily notice that. In fact, just to prove this point, I'm going to go back. I'm going to turn off the talk code. Let me do this so you can see what I'm doing on the thing here. So turn off the talk code. I'm going to run the sample, and I will run sample 2 by itself. Now, if we run this, no, I didn't do the throbbing. Ding dong. Oh, you know, even without the throbbing, to my eyes, even at this scale, it still looks pretty good.
Yeah.
You know, and just so you understand the difference, you can run sample 3. What that does is run both sample 1 and sample 2, and this is the original one, and that had our problem where it would collide incorrectly. But all of the action now will occur using the bodies from sample 2. And it's got a little bit of a lag problem there. I'm not sure what's going on. But so that demonstrates the visuals of what's going on. So let's take a quick look at the code, and then I will show you the editor. Okay, stop running out. Okay. Now, I'm going to leave a lot of this up to the listeners as homework, but I'm going to give you an insight into a couple of pieces. Now, the code here is available to you. It's commented. I think you should be able to figure it out. I just want to run you through what's going on here. First of all, sample 1, it's a module. So I start off, I make a table, and then below I will attach the function run to sample, and I will return sample. And so later in my code, I can say local sample equals require sample 3 for sample 1, and then I can call the function that was attached, which is right here. So we've done this before in previous shows.